Hi, I'm Sheila Murphy. I'm a research hydrologist with the US Geological Survey National Research Program in Boulder, Colorado. I want to talk to you today about the effects that wildfire has on water quality and water quantity. Communities around the world rely on high quality water from forested watersheds. Forests provide a higher quality of water than other land uses such as agriculture or urban areas. For one reason, because there's less pollutants introduced, and another because forests can act as sponges, which slows down rain and snow, and they act as filters, purifying the water as it goes along. So forests are important throughout the world. And how are forests and fires and water connected? I show here a map of Colorado, and the left is land cover, which shows green as forested land, red urbanized land, and yellow is grass or agriculture. And the right shows the areas that we depend on for water supply, based on where people live, where the intakes are, and how many people are served. You can see that the water supply areas overlap with forested areas, so we rely on forests to provide our water supply. The problem is forests are at risk from wildfire. And showing here are the wildfires that have happened since 2000 in the state of Colorado. And not surprisingly, they occur in forested areas, which overlap with that water supply area. So we need to understand, how does wildfire affect water supplies, and what do water managers need to know about the water quality after wildfire? So here's a slide that shows a summary about how a watershed is affected by wildfire. In the diagram from my colleague Brian Ebel, you can see that the forested, unburned watershed has trees with leaves. There's a litter layer on the ground. All these things act to slow down the water, as I mentioned. In a burned watershed, the leaves are gone, the trees are dead, so they're not using the water. The water often runs off of the burned soils very quickly. So we see much more surface runoff and less filtration effect in a burned watershed. And the photos show you some photos of the 4 Mile Canyon fire and what the surface looked like and how steep it is. So you have burned slopes where the water's running off very quickly. And how does a watershed respond? It depends on a lot of factors, but you can get flash flooding that carries a lot of ash and sediment, debris flows, which bring sediment into infrastructure and can cause extensive damage to roads and houses. And you get transport of ash and sediment to reservoirs. Some of the things that affect how bad the water quality is after fire are things like slope steepness, what kind of geology and soil you have, how severe the wildfire was, how much of a watershed was burned, and if the patches of burned area are connected to stream channels. Another important factor is what kind of weather you get right after a fire and for the next couple of years. Do you get low intensity storms or higher intensity storms? That's less well explained in the literature, and that's what our study wanted to focus on, the connection between rainfall and runoff and water quality in a burned area. So today I want to focus on the 4 Mile Creek watershed, which is in the Boulder Creek watershed just west of the city of Boulder. And I show here a couple of maps. The top is land cover, which shows, again, forest in green and urban areas in red. So you can see the dashed outline shows the 4 Mile Creek watershed and the striped area where the burn was. The second map shows burn severity, and this is based on satellite imagery where they can tell from the wavelengths the change in organic matter. So where the fire was most severe, you can see in the map in red. And yellow is moderate and green is low burn. We put our sites, our water quality sites, upstream and downstream of the burned area. So US1 and US2 are upstream, DS1, DS2, and DS3 are downstream. And so we've instrumented the stream for sampling. We're also using data from rain gauges throughout the area, and those are shown as dots on the map. So the 4 Mile Creek watershed was about 23% burned overall, but only 4% at high severity, and that matters when it comes to rainfall and runoff and water quality. So here's a photo of our sampling effort. We went out on a routine basis to collect samples. We also instrumented the stream with automatic samplers, and how that works is in a storm event the water rises to a certain level. We have a trigger in the stream that tells the sampler to start collecting samples. So the gray automatic sampler is up there, hopefully safely far enough away from the water that it doesn't get washed out in a flood, but it can collect samples throughout the event, and the next day we can come back and get them when it's safe to do that. So what did we observe? This is a year's worth of data from after the fire. This is a graph that shows discharge, which is how much water is going by in the top, and the black shows upstream of the burned area, and the red, orange is downstream of the burned area. So in this area during the winter, precipitation falls as snow, and it generally either melts pretty slowly, goes into the ground, and we don't have much water in the stream during that time. We don't see much of a water quality effect. Now when spring runoff comes along, we're getting this snowpack from upstream melting through. Over several days we get a rise in discharge, and it's the same upstream and downstream of the burned area. What we did see in July when there are thunderstorms is we saw a much more sharp increase and higher discharge downstream of the burned area, because the water's falling on that burned area, running off very quickly instead of being slowed down. So we saw increases, rapid increases within 10 minutes downstream of the burned area, which resulted in flooding of the area. And what did that look like water quality wise? Well, as you can see in the graph, we did see higher turbidity downstream of the burned area. And let me tell you that the colors in this graph indicate where the sites are, where the hot colors of red and orange are downstream of the burned area, green is in the burned area, and blue and black are upstream of the burned area. So you can see we do see higher turbidity during spring runoff, but note that it's a log scale on the axis, so above the break it increases by 10 times. So we saw a much higher turbidity during those summer thunderstorms, up to 100,000 NTU, which is extremely high sediment load. And I show a photo there of one of those storms upstream of the burned area compared to downstream. You can see the ash and sediment that we collected in our samples. And I have an example here of that sample collection showing you the upstream area versus the downstream. So these are the samples we collected and then filtered and analyzed for the constituents within. And then moving on to water quality, the next two graphs are nitrate and dissolved organic carbon. These are both constituents that are of concern to human health and have been observed elevated downstream of burned areas. We saw initial flush in nitrate and DOC 3 weeks after the fire during a very minor rain event, which carried ash into the stream. And then we didn't see that much difference again until the thunderstorms of July. You can see in spring runoff times, they're pretty similar. So snow and light rain didn't cause that much of a problem. The issue was with the sediment moving into the channel and bringing with it material that contains dissolved organic carbon and nitrate. So that's when we saw the most impact and when water providers would most need to be concerned about water quality issues. I show here some photos from the biggest storm event during that time, which was the night of July 13th, and we drove up there on the 14th. We saw cars buried in sediment, road crews out already clearing the roads, and you can see in the photo that's downstream of the burned area the day after. So it's still carrying a fair amount of sediment downstream, and there's also evidence of the sediment on the banks of the river there. So what are the water management implications of wildfire and runoff? Well, there are a few. We observed that wildfires and the subsequent storms can have short-term and long-term effects on the water supply. Those brief but really high increases in sediment and dissolved organic carbon can decrease the efficiency of your water filtration system, your pathogen removal, and can increase the risk of carcinogenic byproducts when you chlorinate. The increased loading to reservoirs of carbon, nitrogen, and sediment can impair your reservoir in that it fills a reservoir, so it's got a shorter lifetime. You may need to spend more money on dredging the reservoir. Denver Water spent $26 million on their reservoirs after a couple of wildfires. Climate change is predicted to increase wildfire frequency and size, and along with a possible increase in storm frequency and intensity. That combination could lead to more wildfire problems in the future to water supplies. which would compound the problems already of increasing population and possible decreases in runoff because of climate change. I show here in this photo Barker Reservoir, which is one of the primary water supplies for the city of Boulder. Fortunately has not had a wildfire in recent years, but say it did, some of the issues would be, as I mentioned, higher sediment loads, possible requirements of dredging. What can water managers do to ameliorate some of this risk in their system? Some possibilities are, if you have an off-channel reservoir, fill it during the spring before those thunderstorms and shut off intakes during thunderstorm season. Establish an alternative water supply. This is hard with water rights in Colorado, but Fort Collins did it when they were subjected to a fire. They switched their supply that they usually rely on to avoid the wildfire affected water. You can construct a sediment basin before it goes into the reservoir, and you can increase your sedimentation capacity at water treatment plants. Another option is to install real-time monitoring networks to warn you of high turbidity or flooding before it reaches your plant. If you'd like to get more information about our study, please visit the website that has our fact sheet. We have some other publications that are referred to within that fact sheet and more on the way. And if you want to learn more about the USGS when it comes to land cover or hydrology or any things I talked about today, please visit our website at usgs.gov/water. Thanks.